Okay, this is the last part for the homework of the section 6.4. Question 83. Domain of the function f is obvious or real number because it's exponential. Let's do in the graph. The graph is, this point, typical point, is 0,1, and the rest is no easy because it's exponential. It's a rational number, so it's not good to see what it is. And 1 is e, and -1 is 1 over e. Okay, but this is not good to see. So now, approximately, roughly, the color look like that. Which is e to the x. This is a basic function. Now we have a transformation. E to the x is transformed like a e to the x plus 2. So in this case is typical horizontal shift to unit to the left. At this point it's become like a 1, 2. This is here. This point become like a -2,1. And the horizontal asymptote stays the same, doesn't change. This is the horizontal asymptote, y equals 0, stay the same. And this is the new core, e to the x plus 2. Now, after that we have ex plus 2 minus 3, que is vertical shift 3 unit down. In this case, yes, the horizontal asymptote change, and the equation is -3 right now. And this point change to the subtraction 3 here is -2, -3 is -2, -2. It's a coincidence, -2, -2 here. At this point is -2, -2. Now let me use the magenta color a little bit more dark, bold. So this is magenta. So it's like that, approximately. This is the graph of the original function, because the original function is this e to the x plus 2 minus 3. Okay, the range, look in the graph of the f function is negative, from -3 to infinity. Entonces y such that y is greater than -3. Okay, now let's find the inverse. The inverse symmetry. The inverse function. Okay, the inverse function. This is y equal e to the x plus 2 minus 3. Now interchange x and y. Now solve for y. X plus 3 is equal e y plus 2. Apply natural logarithm because it's the logarithm associated with the same base. Natural of e to the y plus 2 cancels out. This is natural logarithm x plus 3 is equal y plus 2, then y, que is the inverse function, is equal ln x plus 3 minus 2, and this is the inverse function. Okay. The domain for the inverse function is, okay, the restriction is obvious, taking this as x plus 3 greater than 0, x greater than negative 3. Is x such that x is greater than negative 3. This is the same idea of this. This is this and this. But this is a range of the origin, and this is domain for the inverse. And the range for the inverse is obvious, it's all real number. Okay, let me try to do the graph approximately. Okay, now see, this is the asymptote, then the horizontal asymptote was equal minus 3. We have one vertical asymptote and minus 3, x equals minus 3 here. Okay, negative 1, negative 2, negative 3 here, approximately. This is the vertical asymptote, x equals minus 3. Now the line 1, 1, 0, 0, the identity is like that, y equals x. Now this is not accurate idea. The inverse function look like that. This is asymptotically. Okay, and this is associated, of course, with this expression. So this expression is ln x plus 3 minus 2. It's the inverse function. Super perfect. Okay, 85 is the last one in this section. Wow, finally. Is, okay, domain. Domain of the function f is all real number because it's the exponential function. This is obvious. Let me try to do the graph. The graph. xy. Okay, this is the typical exponential. We start for the classical point 0, 1, and negative 1. So this point is a point 0, 1. This point is 1, 2. And this point is negative 1 half here. And this is the exponential, 2 to the x. Now, transformation number 1. 2 to the x is transformed 2 to the x over 3. Okay, this is like a typical horizontal stretch. Why? Because suppose here 3 and 3 here, so you're putting in 3 is 1, 2, and 3. The answer is the same, right? It's the same like in 1, because 3 divided by 3 is 1. So this point, okay, normally is the point 1, 2, right now would be 3, 2. And this, no, this stays the same, and this of course change. So this change a little bit like that. To x over 3. And of course, the asymptote, the vertical asymptote, the horizontal asymptote, sorry, is the same, doesn't change. Now finally plus 4. Plus 4 is you moving is 2x over 3 plus 4 is typical vertical shift for unit O. Entonces 2, 3, and 4. This is a new asymptote. Y equals 4. And this point is 3,2 would be 3,6. 4, 5, 6, 6. And this point is now wait, let me erase this part. Okay, now this point is 4, 1, 2, 3, 4 here. And this is 1, 2, 3, and 4. This is here 6. 6. This is 1, 2, 3, 4 here. Okay, so our exponential look like that. This is 2x over 3 plus 4. Okay, typical point, typical point. This point is the point 0,5. And this point is 3,6. 3,6. 4, 5, and this is okay, approximately that. Okay, let me use the magenta color. Magenta, magenta. Okay. Now the identity curve, identity line is something like that. Y equals X. So this point is 4, 5. 5 here, 5,0. 5,0. This is 5,0. There's this point in blue. And the other point is 6,3. This is 6, 3. 1, 2, 3 here. 6,3. Okay, this is 6,3. Okay, so you approximately connecting here. Okay, is okay. Now let me see the asymptote. We have the vertical asymptote at 4 here. This is the vertical asymptote. X equals 4. And this continue here. Approach it but never touch this. Okay, good. Not bad. Now the final part is the well, the domain. Let me set out here. Domain of the function f is a real number, and the range of the function f, look in the graph, is from 4 to infinity. Entonces es 4, infinity. O y such that y is bigger than 4. Now domain of the inverse es obvio que es x such that x is greater than 4. And the range of the inverse is all real number. Okay, finally, let's try to find the expression for the inverse. So I copy. Y is equal to x over 3 plus 4. You interchange x and y. And solve for y. Apply logarithm base to both sides. And this is y over 3. And multiplication by 3 is 3 times is equal to the new y, que es inverse function. And this is the expression que corresponde with the inverse function.